Greetings, ladies and gentlemen. My name is Donnie, and today's video will be solving for x using the Lambert's function, W function, or another way to say it is the product log function. The first step is to understand the formula. So the main goal of this, right, is to get inside this format where we have some y and e raised to some y. Now, the y could be anything. It could be x squared, it could be ln x, something like that, okay? Something that's some other function, right? And we need to get inside this format. And once we get inside this format, we can replace this whole contraption over here to a singular y, which in any other scenario could be x squared, something like that. And after we get some w function. Don't be scared, because a w function is similar to log, ln. It's very similar to that, okay? And the w function has something unique with it. It has a branch number. And I'll be explaining that later on in the video when we explore the graph of the Lambert's function. Now, the first step is to try to get inside this format, okay? So we're going to bring the x on the other side. We're going to divide by 2 to the power of x, right? And we left off with this. Now I'm going to rearrange, bring this 2 to the x onto the top so it's going to have a negative. We're going to multiply by 2 to the power of 5 on both sides, because you're trying to get familiar, okay? We need the top and the bottom to be the same. Now, once we done that, now we have a bit of a problem over here. We have the top and the bottom to be same, but we have a 2 over here instead of an e. Well, there's a rule for that. We convert this 2 over here to e to the ln 2, and this is a rule. We're not changing the value of 2. It's just another way to represent it, and this is how we do it. So we're going to have to apply it in here. And we left off with this. Now we're going to multiply this 5 minus x to the ln 2. Okay? So we multiply it in. And now we're going to have to multiply ln 2 on both sides because we have to get it to the same. The top is different compared to the bottom over here. So we multiply ln 2 on both sides. Okay? And now we're going to apply w. Right? Because they're the same on the top and bottom. And now this results into just 5 minus x ln 2, and here we have a w. Okay, divide ln 2 on both sides. We bring the 5 on the other side, and after we let the signs flip because we have a minus over here, and we're going to have x equal to 5 minus w 32 ln 2 divided by ln 2, and that's our function rule. Now we're going to proceed to the graph. Okay, so here's the Lambert W function's graph over here, okay? The first step is getting back to our rule over here. And we're going to solve for this. We're going to do 32 multiplied by ln 2, which is x equal to 22.1807. Now, it's located right over here as in the graph, right? It's located right over here. This pink line is represented by 22.1807, and it intercepts at 2.27656, okay? So this is our point. Now I'll be explaining this whole graph. So branch of 0, of w of 0, sorry, is this orange line, okay? Now, branch negative 1 is this green line over here, as you can see. It goes outwards and it comes right in. It tries to touch the y-axis, okay? So it's this green line over here. And the asymptote over here is negative 1 divided by e, which is this blue line over here, okay? So now, what we know about this, right? Well, case 1, if x is greater than 0, right? In our scenario, it is greater than 0. It's 22. So it's greater than 0, so we're going to have one real solution. Let's say if we had a different type of case. Well, if we had case 2, if it was between the negative 1 divided by e asymptote and 0, we're going to have two solutions. In case 3, it means that if 1 or 2 doesn't work out, it means that we have infinitely many complex solutions. Well, in this scenario, it's case 1, so we're going to write w of 0. And we're going to replace this whole portion over here with 2.276, which is found in the graph to be over here. Okay? And now we solve this, we plug inside our calculators, and we should acquire an answer of 1.7156. And that's the final answer to this question. So please leave a like and subscribe, and I hope you guys have a wonderful, great day.